So in this lecture, you're going to understand the concept of privilege level. So every time you learn about the privilege mode, you may hear about privilege level. The privilege mode corresponds to the privilege level, so it is important to understand what the privilege level is, because every time you look into the documentation of RISC-V architecture, and you may notice that the privilege mode is related to privilege level. Let's review the RISC-V specification, which describes the privilege level. At any time RISC-V hardware thread is called heart, is running at some privilege level encoded as mode in one or more controlling status registers. And this table outlines the privilege level in RISC-V architecture. So lowest privilege level is privilege level 0. And privilege level 0 is corresponding to the user mode in RISC-V architecture. As now, in the user mode, the user application is executed. And there is another privilege level, that is privilege level 1. So privilege level 1 is corresponding to the supervisor mode. So S stands for the supervisor mode in RISC-V architecture, and like the supervisor mode, the user mode can be represented using the U. Then the privilege level 2 is reserved, and the highest privilege level is 3, privilege level 3, and privilege level 3 is corresponding to the machine mode. The machine mode is most important privilege mode in RISC-V architecture, because you have to implement the features in the machine mode when you develop your project in RISC-V architecture. So in summary, the concept of privilege level is corresponding to the privilege mode. So remember that, and the highest privilege level in RISC-V architecture is privilege level 3, that is corresponding to the machine mode, and lowest privilege level is privilege level 0, which is corresponding to the user mode in the RISC-V architecture. Then the RISC-V documentation can specify the usage model of privilege mode with privilege level. So when you are about to design your whole system, and you may be in the situation to which privilege model should be used. And if your system requires the simple specification or features, then simple real-time operating system or bare metal software can be implemented. In this case, all of the software features can be implemented in the machine mode. So in this case, there is one privilege level in the system, that is machine mode. In some cases, your embedded system requires so much more the specification than this case, and then user application can be implemented in the user mode, and our real-time operating system or advanced real-time operating system can be implemented in the machine mode. In this case, your software architecture is consisting of the privilege mode, such as machine mode and user mode. In this case, the machine mode is corresponding to the privilege level 3. In case of the user mode, it is corresponding to the privilege level 0. In this case, I can say that there are two privilege levels in the system, And as for in this case, and the motion mode can be used to support the security feature, and the supervisor mode, like Linux kernel, can be implemented or executed in the supervisor mode. In the user mode, user application can be executable in the user mode. So in this case, there are three privilege level: privilege level 3, privilege level 1, privilege level 0. So decision to choose the appropriate privilege mode is selected by you, your systems of the engineer. So in order to choose the appropriate kind of the privilege mode in your system, and you need to understand the detailed concept of each privilege mode with the privilege level. So in this lecture, you understand what the privilege level is and the correlation between privilege mode and the privilege level. The next lecture, I'm going to show you another detailed concept of privilege mode and privilege level in the RISC-V architecture.